Welcome students, welcome to the topic of derivatives. Myself Rushali Pagare, faculty of KK Polytechnic Nasik. The concept of derivatives along with integration occupies a central place in calculus. Finding derivative is also called as differentiating. It is inverse of integration. The derivative of a function at some point is the rate of change of that function at that point. It is the ratio of change in the dependent variable denoted by delta y to the change in the independent variable denoted by delta x. Now let us see the notation. Consider the function y is equal to f of x, where x is the independent variable and y is the dependent variable. Then by Lagrange's notation, derivative is denoted by f dash x or y dash x. And by Leibniz notation, the derivative is denoted by dy by dx or df by dx. Consider the curve y is equal to f of x. Consider any point A on that curve. Draw a tangent at that point A. Then geometrically, derivative dy by dx of the function is slope of the tangent to the curve y is equal to f of x at that point. Let y equal to f of x. Y is the dependent variable and x is the independent variable. Then slope is equal to change in y upon change in x. It is same as small change in y upon small change in x, which is equal to delta y upon delta x. Now let x change from x to x plus h, then y will change from f of x to f of x plus h. That is, we replace x by x plus h in y. Since y changes from f of x to f of x plus h, then change in y denoted by delta y is equal to f of x plus h minus f of x. And x changes from x to x plus h, so change in x, that is delta x, is equal to x plus h minus x. So the ratio delta y upon delta x is equal to f of x plus h minus f of x upon x plus h minus x. So in the denominator x will cancel. So delta y by delta x is equal to f of x plus h minus f of x upon h. Now take limit as h tends to 0 on both sides. So limit h tends to 0, delta y by delta x will become dy by dx is equal to limit h tends to 0 f of x plus h minus f of x upon h. Finding the derivative by this formula is called as differentiating by first principle. Now let us see the formulae for finding derivatives of standard functions. Algebraic functions first. Derivative of x raised to n, where x is a variable and n is a constant, is equal to n x raised to n minus 1. Derivative of root x is equal to 1 upon 2 root x. Derivative of x is 1, whereas derivative of constant k is 0. Now exponential functions. Exponential means raised to. Derivative of a raised to x, where a is a constant, is equal to a raised to x into log a, whereas derivative of e raised to x remains e raised to x. Derivative of logarithmic function. Derivative of log x to the base a is 1 upon x into log a, and derivative of log x to the base e is 1 upon x. Now derivative of trigonometric functions. Derivative of sin x is cos x and derivative of cos x is minus sin x. Derivative of tan x is sec square x, whereas derivative of cot x is minus cosec square x. Derivative of sec x is sec x into tan x, whereas derivative of cosec x is minus cosec x into cot x. Observe that derivative of all the functions beginning with c has minus sign. Now derivative of inverse trigonometric functions, derivative of sine inverse x is 1 upon under root of 1 minus x square, whereas derivative of cos inverse x is same as derivative of sine inverse x but with minus sign, that is minus 1 upon under root of 1 minus x square. Derivative of tan inverse x is 1 upon 1 plus x square, whereas derivative of cot inverse x is same as the derivative of tan inverse x but with minus sign, that is minus 1 upon 1 plus x square. Derivative of sec inverse x is 1 upon x into under root of x square minus 1, and derivative of cosec inverse x is minus 1 upon x into under root of x square minus 1. And now the rules of differentiation. We know that derivative of constant is 0, so that is the constant rule. Derivative of x raised to n is n into x raised to n minus 1, where n is a constant, is called as the power rule. Now the constant multiple rule, that is scalar multiplication rule. Derivative of c into u, where c is a constant and u is a function of x, is equal to c into du by dx. Now the sum and difference rule, that is if u and v both are functions of x, then derivative of u plus or minus v is equal to derivative of u plus or minus derivative of v. The product rule, derivative of u into v is equal to u into derivative of v plus v into derivative of u. The quotient rule, that is derivative of u upon v is equal to v into derivative of u minus u into derivative of v upon v square. Okay, students, hope you have understood the basics of derivatives and you'll start taking interest in the chapter of derivatives. Good luck and thank you.